Hi, everyone, and welcome. I'm Elizabeth, and I'll be guiding you through today's webinar. We're excited to have you here for a deep dive into AI-assisted coding in practice, successes, failures, and engineering trade-offs. This is a part of our ongoing series where we explore real-world engineering challenges and cloud development strategies. Our speaker today is Andrei Veremy, a senior software engineer with over 6 years of experience. He's certified as an Azure Solutions Architect and brings hands-on expertise in .NET Core, ASP.NET Core, Angular, microservices, and Microsoft Azure. Andrei will walk us through how AI coding tools are actually used in development teams, from boosting productivity to handling pull requests and CI, all the way to addressing real concerns about AP and compliance. So let's get started. Over to you, Andrei.
Yes, thank you, Elizabeth. Welcome, everyone. Yeah, I can see we've got folks joining from all over, so thank you for making time. Today we are talking about AI-assisted coding, the way it actually appears in real engineering teams, not how we used to see it in vendor demos. And what I want to be upfront is that this session is going to be tool agnostic and experience-driven, and also deliberately honest about the trade-offs. So here is what I'm not here to do. I'm not here to argue whether AI is good or bad. Honestly, I find that kind of debate exhausting and not really productive. So the real question is much more specific. Where does AI actually help? Where does it quietly hurt? And most important, how do we use it intentionally instead of using it accidentally? So let me tell you why this matters. I have a story. Like about 6 months ago, I was reviewing a pull request. Clean code, good tests, merged in around 20 minutes. 2 weeks later, we had a production incident. And turns out the code had a subtle race condition that AI had confidently introduced, and neither the author nor I caught it in review because it looked so, professional. So that's when I realized we need to talk about this differently, and we need to treat it differently. Not should we use AI, but when should we use it, and how do we know when we shouldn't? If you are already using an AI tool, and statistically most of you are, this talk helps you to use them better. And if you are considering wider adoption in your team or company, this talk helps you to avoid expensive mistakes. So if you are skeptical, well, I mean skeptical about the AI tools, I promise we'll validate some of your concerns with real data. But anyway, we have to deal with it, and this is how the world changes right now. So let's start where we are today. As you can see on the screenshot, this is what I meant by being honest in this conversation, actually. So on the left, you've got the demo from the vendor, and everything looks pretty nice and clean, and it works. And on the right, you've got some, Tuesday afternoon when the AI just suggested you to use a new library, which is actually an old one, and it's been deprecated for 2 years and has some known CVEs. So I'm showing you this not to bash AI tools because they are incredibly useful still, but to set the tone. We're going to talk about the reality, not aspirations. AI coding tools didn't arrive through a formal rollout plans or carefully considered adoption strategies as some other tools in our industry used to do. They are out through just IDE plugins, some browser tabs, and just try it once moments that turned into daily habits. So let me give you a concrete example. Almost a year ago, I talked to a CTO. It was a Series B startup, about 40 engineers, and he asked me, should we allow AI coding tools on the project at all? I said, let me check something first, and we did a quick survey. So it turned out that 32 of his 40 engineers were already using AI tools. And the question wasn't, should we allow it? It was, should we acknowledge that what's already happening and give it some structure. So this is the landscape where we are in. Most teams are already using AI in some form, and often without a shared understanding of where it's allowed and how much to trust it, or who is accountable for the output. And here's where it gets interesting. When survey says developers regularly use AI, the important question is, what does this regularly actually mean? Are we talking about drafting boilerplate, designing systems, or fixing production bugs? I think those differences matters. And they matter a lot. Because using AI to generate a CRUD endpoint is fundamentally different from using AI to architect a distributed system. And same tool, radically different risk profiles. Think about your own team for a second. If you were to ask everyone right now how they are using AI, you'd probably get widely different answers. That gap between individual practice and shared understanding is where most of the problems start. So I'm intentionally avoiding the vendor names here right now, and that's deliberate. What matters isn't the brand in reality, it's just the interaction model. Different models create different risks and different value propositions. So IDE assistants, they feel like autocomplete on steroids. They're fast, contextual, and sometimes intrusive. You are typing along and suddenly there is a suggestion. You hit tab. Did you read it? Did you understand it? Maybe, or maybe not. Chat-based tools feel like an always available teammate. They're excellent for exploration and explanation. But here's the danger. They are dangerously confident, and you probably have noticed that when using them. I watched AI chat tool explaining incorrect code with the same tone of certainty they are using for correct code. So there is no hesitation. No, I'm not sure about this part. And let me tell you what this looks like in practice. A developer on my team, like smart guy, 5 years experience, asked an AI chat tool to explain a cryptographic function. The AI gave him a beautiful, well-structured explanation that was kind of 70% correct and around 30% completely wrong. He didn't know enough about cryptography to spot the errors, so he internalized the wrong information, and we only caught it 3 weeks later during a security review. So this is how it works. Also, another category is specialized tools, and those are interesting because they have a narrow scope, but high leverage when used correctly. A tool that only does one thing, like generating tests or scanning PRs, can be incredibly valuable because its failure modes are limited and easier to spot. So most teams don't use just one of these. They use a combination and often inconsistently across the team. And that's not necessarily the bad thing, but it does mean you need to think about the aggregate effect, not just individual tools. This mockup is made of a real screenshot from a developer on a team I consulted with. Notice anything wrong here? They've got 3 different AI coding assistants installed, and when I asked why, the answer was basically, well, this one is better for Python, this one is better for explaining code, and this one, I forgot why I installed this one. This is a tool sprawl, and the problem isn't that these tools exist. It's that nobody thought about how they interact, what data they are all sending, and whether the team has any shared mental model about them. All right, let's talk about the reality. Here is what we consistently see across dozens of teams we've studied. AI is used mostly for tactical work, not strategic decisions. And that's actually smart. Boilerplate generation is everywhere, like CRUD endpoints, DTOs, data mappings, test setup, all the stuff that's tedious but follows the patterns. This is AI's sweet spot, let's call it. I watch engineers generating a complete REST controller in 30 seconds that would have taken them like 20 minutes to type out manually. So this is the area where we have high value and low risk. But here is the most valuable use case that nobody talks about enough, is explaining in the existing code, especially legacy code. I worked with the team that inherited a code base from an acquisition, and the original team was gone. Documentation was sparse. They used AI to basically create an oral history of the code base. So they just typed, what does this function do? What might it be structured this way for? And the answers were not perfect, but incredibly useful for onboarding. So now let's talk about what doesn't happen often. Good teams don't often delegate architecture to AI tools. They don't let AI design system end-to-end, and the teams that try that, they usually regret it quickly. So here is another story that will stick with you and explain why. A startup, Series A this time, moving fast, decided to let AI design their notification system. How hard it can be, they thought. And AI suggested a beautiful, clean architecture, microservices, message queues, the workers. They built in 3 weeks instead of 6. But 8 weeks later, they had to rewrite the entire thing. Why? Because the AI designed system didn't account for their actual scale patterns and didn't consider their specific reliability requirements, and made assumptions about database transactions that were fundamentally incompatible with their existing infrastructure. The gap between the AI, where AI is good at what it is marketed for, that's where many problems start. Because AI can help you build things faster, but it cannot replace the judgment. And that comes from understanding your specific context, your specific constraints, and your specific trade-offs. Here is another model. This is a mental model I recommend to every team I work with. Here we have some risk zones. Those are not just binary can or cannot. So let's start with the green one. The green doesn't mean no review needed at all. It means usually produces a usable starting point. Think boilerplate, test structures, documentation drafts. The key characteristics, like these are tasks where the pattern is clear, the scope is bounded, and mistakes are obvious. Example, I needed like 20 unit test skeletons for data validation layer, and AI generated all 20 in about 2 minutes. Were they perfect? No, not at all. But did they save me an hour of typing? Absolutely. And I reviewed them, tweaked a few, and moved on. Yellow zone is where it gets interesting. This is refactoring, bug investigation, and API integration. Tasks that require interaction, verification, and actually understanding why the code works. AI can help you, but you need a strong judgment here. Here is a yellow zone story. We had a performance issue in a search service. A developer asked AI to help optimize it, and AI suggested adding an index, restructuring a query, and caching some results. So all reasonable suggestions, aren't they? But the developer implemented all 3 and performance got worse. And turns out, in the context of our specific data distribution and query patterns, one of those optimizations was counterproductive. The AI didn't know that. It couldn't know that and gave generic advice that looked smart but missed specifics. And that's why like a single change made it even worse. And now the red zone, the last one. This is where AI often produces a pleasurably looking but subtly wrong code. Complex business logic, security critical path, distributed systems, anything involving concurrency, everything of this is here. The most dangerous situation is when AI is confident, the code looks clean, and the mistake isn't obvious. I've seen this pattern over and over. Clean, well-formatted code that passes tests, but has a subtle logical flaw that only surfaces in production under specific conditions. The real example here is an AI-generated authentication check that worked perfectly, except it had a subtle bypass when the request contained certain Unicode characters. Beautiful code, horrible bug, and it looked so professional that it passed 3 levels of review before someone caught it during a security audit. So this is what happens in the reality. Let's take a look at the example again. Look at this code. On the left, you've got beautiful, professionally looking code. Clean structure, proper async await patterns, good error handling. It checks inventory before charging the customer. It has all the hallmarks of well-written C# code. This would sail through most of code reviews, and I've shown this to senior engineers and asked them to spot the bug. Most don't see it immediately. Now look at it at the right side. Same code, but annotated to show what actually happens under load. This is a classic race condition, and this is exactly the kind of a bug AI generates because AI doesn't think about concurrency. Let me walk you through what happens here. Imagine it's Black Friday, for example, and you've got one item left in stock. 3 customers click buy now at exactly the same time on your website. Request A reads the database. The stock count equals 1 and passes the check, good to go. Request B, at almost the same instant, reads the database and stock count still equals 1, also passes the check. And request C, same thing, reads the stock and it still equals 1, and all 3 requests think they are buying the last item. Now, here's where it gets interesting. All 3 requests hit that await when they call the payment gateway. And that's an async operation. It takes maybe 200 milliseconds. And during that time, the async runtime can context switch between all these requests. All 3 payments succeeded. And all 3 requests come back from the await, and all 3 of them execute product stock count decrement. So 1 item in stock, 3 successful sales, and inventory goes negative. Now you might be thinking, well, doesn't the database handle this? But not the way this code is written. Entity framework is doing a simple read, modification, and write. So there is no lock-in, no optimistic concurrency, no atomic operations. This is a textbook lost update problem. The real insidious part here is every single unit test passes because unit tests typically run sequentially and 1 request at a time. The race condition only manifests under actual concurrent load. So I know this because I've seen exact pattern in the production environment. Not with AI-generated code initially. This is a mistake humans have been making for decades. But here's the thing. Humans who've been burned by race conditions once learned to watch for them. And they learned to think, wait, what happens if 2 requests hit this at exactly the same time? AI doesn't learn that way. AI sees thousands of examples of payment processing code, most of which don't handle concurrency properly, and it happily generates more of the same, clean, readable, but broken code. The fix requires thinking about the problem differently. You need either optimistic concurrency with a raw version, or you need pessimistic lock-in with database level select for update, or atomic operations that do check and decrement in a single database command. AI didn't suggest any of those. It went with a simple, clean approach that looks great and fails under load. Of course, you may argue that you need to be more clear when you are prompting AI to do something like that. But that's the key to this issue, because it will not do the work for you. You should be aware of the pitfalls yourself to instruct the AI properly. This is what I meant earlier about the gap between code that works and code that works under production conditions. The first time you deploy this, it will be fine, and light traffic, sequential requests, everything works. And then you get featured on TechCrunch or Black Friday, or there is a limited time sale, and suddenly you've got hundreds of concurrent requests, and your inventory system is chaos. Negative stock counts, overselling, angry customers who got charged for the items that they can't receive. And when you dig into the logs trying to figure out what happened, the code looks perfect because it is perfect for the happy path, but single-threaded scenario, and AI was trained on exactly this scenario. This is why code review for AI-generated code can't be faster. It has to be different. You can't just ask, does this logic make sense? You have to ask, what happens under load? What happens with concurrent requests? And what are the failure modes? Those are the questions that require experience, and that's why I worry about junior developers who are using AI heavily without that experience to fall back on. So let's take a look at this now. Greenfield projects are AI's happy place. There is less history, fewer constraints, modern frameworks, and clear patterns to follow. AI can genuinely accelerate development here, but, and this is a big but, early decisions stick. AI can help you move fast and help you bake in problems permanently. Let me give you a concrete example again. A team was building a greenfield project with modern stack, TypeScript, React, the whole 9 yards, and they used AI heavily for the initial architecture. Everything looked great. Clean separation of concerns, good test coverage, modern patterns. 6 months in, they realized they'd structured their data models in a way that made a critical business feature almost impossible to implement. Not because the code was bad, it was quite good actually, but because the AI had made assumptions about data relationships that seemed reasonable in isolation, but were wrong for their specific domain. And to fix it required rewriting around 30% of the code base. If a human architect had made that mistake, they probably would have caught it earlier because they would have been thinking about the business domain, not just about the technical patterns. Legacy systems are different. AI cannot see tribal knowledge or historical failures, or we tried this before constraints. It sees code, but it doesn't see context. So here is where AI shines with legacy code, explaining ugly code and summarizing behavior. For example, what does this 400-line function actually do? That's AI great use case. The AI reads the code, you read the AI summary, you verify it, and you save yourself an hour of tracing through nested loops. But here's where it fails, refactoring across implicit constraints. I watched a team try to use AI to refactor a legacy payment system. The AI suggested beautiful, clean changes that would have broken 3 external integrations that weren't documented anywhere in the code. With legacy code, use AI as a translator, not as a surgeon to make some critical changes. And let me tell you about real defensible productivity gains we've measured across the teams. The common traits of high-value AI use cases is bounded scope and easy to verify low blast radius. These aren't exciting or glamorous, but you can spot that they are where AI consistently delivers. And test generation is my favorite example because it perfectly illustrates the pattern. AI is excellent at structure, but terrible at intent. Here is what it looks like in practice. I needed to write tests for a data transformation pipeline. 17 different transformation functions. Each needed happy path tests, edge cases, and error handling tests. It's probably around 60 plus test cases. So I asked AI to generate the test scaffolding, and it gave me a perfectly structured test files with described blocks, test cases, and basic assertions. It probably saved me 2 hours of typing, and it is critical, but every single test assertion needed to be manually verified because AI does not understand what the correct output should be for my specific business logic. If you treat AI output as scaffolding, it saves you time. If you treat it as a final, it creates false confidence. And I've seen teams ship AI-generated tests that all passed, but didn't actually test the right things. So documentation drafts are similar here. AI is generating a good structure and first drafts. So something that works is generate API documentation from these TypeScript interfaces. It's excellent use case. But generate user documentation that explains complex business rules is a terrible use case because AI doesn't know which details matter to your users. So the pattern is AI is a force multiplier for tasks where you already know what good looks like. But you can also verify the output quickly. And for all other cases, it's probably may bake in some issues that you will face much later. So you will just move the timing to resolve them. These are not never use AI areas. These are never trust it blindly areas. And I want you to empathize that distinction because it matters. And let's talk about security first. AI often misses edge cases and may introduce vulnerabilities that look harmless, but a real story here comes. A developer asked AI to help to implement input validation, and AI generated a nice regex pattern that validated email address. Something very trivial and looked good, worked in testing, passed all the test cases they threw at it. And 3 months later, security audit, the regex had a catastrophic backtracking vulnerability. Under certain inputs, it could cause the application to hang for several seconds. Didn't matter in low volume testing. Mattered a lot in production, and that's where the critical issue comes. Performance is similar. AI suggests generic solutions without profiling. How do I make this query faster, you may ask? AI says, add an index. And sure, maybe, but which index, in which table? Does it actually help for your specific query pattern or data distribution? I watched a team adding 5 indexes based on AI suggestions. And obviously performance got worse because now writes were slower and the query planner was confused. They had to remove 4 of them and leave just 1. So that's something that we should learn from. And business logic with implicit context is also where AI fails in ways that are mostly invisible. AI doesn't know which rules are intentionally missing. It doesn't know why you are not validating certain fields. It doesn't know about the informal agreement between your team and another team about how data flows. Here is an example that keeps me up at night. A financial service company used AI to refactor some transaction processing code. And the AI cleaned it up beautifully, like removed what looked like redundant checks, simplified the logic, made it more readable. Deployed to production, everything worked fine for 2 weeks. Then they got a call from a partner bank and saying, your transactions are failing on our reconciliation process. Turns out that one of those redundant checks was actually enforcing an implicit constraint that the partner bank required but wasn't documented anywhere. The original developer knew it from a conversation 3 years ago. The AI don't. Distributed systems are maybe the scariest part. Retries, ordering, idempotency. AI gets this wrong in very believable ways. It will generate the code that works perfectly in testing and fails in production under network delays or partial failures. This is where clean code becomes dangerous code. It looks right, pass tests, and then it fails in production in ways that are hard to diagnose. So let's take a look at the example. This is from a real incident last year. Notice the timeline. The code deployed late Friday afternoon. Everything looked fine. Production incident at 2 a.m. Saturday. What happened? AI generated a retry logic. It looked great, handled failures, retried requests, logged appropriately, but it didn't implement exponential bake-off. When an upstream service had issues, the retries created a thundering herd that made everything worse. This is what I meant by fails silently. The code worked, the test passed. The problem only appeared under production load in real-life conditions. So almost every team reports the same thing initially. We feel much faster with AI. And you know what? That feeling is real. You're typing faster, you're getting to a working version faster. But when you measure end-to-end, the picture changes. Here is data from a team we studied over 3 months. They adopted AI coding tools heavily. We measured time to first working version and time to code review approval and time to production. First one is impressive. Time to first working version was like 40% faster than it used to be. Time to code review approval was around 15% slower. Why is that? And time to production is roughly the same. What happened? AI doesn't remove the work. It moves it. And the time you saved writing code moved the code review. Reviewers had to verify understanding, check it for hallucinations of AI, validate dependencies, and what used to be a 20-minute review became a 35-minute review. Because the reviewer couldn't just ask, why did you implement it this way? They had to ask, did you even understand what AI generated? And do you know why it works? So let me tell you about a specific PR that crystallized for this for me. 400 lines of code, mostly AI generated, implementing a feature that probably would have taken a developer 2 days. So the PR sat in review for 3 days, not because it was bad code. It actually was quite good, but because the reviewers kept finding subtle issues that the author hadn't noticed, and the author had generated the code fast, but hadn't deeply understood all of it. In the end, we got to production at about the same time we would have spent without AI. So with a different distribution of effort, we end up with the same timing. Is it bad? Not necessarily, but it's not a miracle productivity gain that gets advertised by AI vendors. And this is the part nobody puts in marketing slides. So let's talk about it honestly. AI-heavy PRs often take longer to review, not always, but often enough that it is a real pattern. Why? There are 4 main reasons. First, reviewers must verify the author actually understands the code. Before AI, if code worked and looked reasonable, you could generally assume that the author understood it and because they wrote it. With AI, that assumption breaks down. You can't tell by looking at the code whether the author understands it. Second issue is AI tends to over-engineer. It will use design patterns you don't need and abstractions that aren't justified and generally write code that looks more sophisticated than it needs to be. However, the main rule in our industry is also to keep it simple. So that's harder to review than simpler code. Third thing is hallucinated dependencies sleep in, and that's what I often see. I've reviewed PRs where AI imported libraries that don't exist, called functions with incorrect signatures, or used APIs that were deprecated years ago. This aren't obvious, and if you are scheming specifically. And fourth issue here is security, and edge cases needing extra attention. AI-generated code always looks professional, which creates a false sense of security, and you have to actively remind yourself to check for subtle problems. Some teams now explicitly flag AI-assisted PRs for deeper review, and that's the right thing. It's not as punishment, just as acknowledgement that these PRs need a different kind of attention. Here is a practice I've seen work well. When you submit an AI-heavy PR, you include a comment explaining which parts you generated, and which parts you modified, and which parts you specifically reviewed for correctness. That transparency helps reviewers focus their attention on the right parts, and you can't safely review AI code faster. You can only review it more carefully and adopt new strategies. So, AI changes how teams learn, and we are only beginning to understand the long-term implications of that. Best case scenario would be juniors are using AI to unblock themselves on syntax and patterns, then discuss the why questions with seniors. The AI handles the tactical, human handle the strategic part. And this can actually accelerate learning if done intentionally. So I saw this work beautifully with a junior developer last year at our company. She was learning Go language and she used AI to generate the basic structure of handlers and middleware. Then bring questions to senior engineers like, why did it use this pattern? What are the trade-offs? When would I choose differently? And so on. AI accelerated her learning because it let her focus on concepts instead of syntax. She wasn't copying blindly. She was using AI as a force multiplier for her learning process. And the worst case scenario comes when juniors become AI operators. They can ship code, but they don't understand it deeply. So foundational skills don't develop. A real example that worries me, a junior developer who'd been on the team for 8 months, smart, capable, and getting things done. Then there was an internet outage for about 4 hours, and he basically couldn't work. Not because he needed to Google things, everyone does that, but because his entire workflow was built around AI. Without it, he was lost. He was kind of prompt engineer more than a developer. So that's not his fault, that's a systematic failure. We'd let him optimize for short-term velocity without building long-term capability. This raises a hard question that teams need to grapple with. Are we optimizing for short-term velocity or long-term capability? Because those aren't always aligned. Strong teams use AI as a technical aid. They encourage juniors to use it, but they also create space for learning that don't involve AI. And they have seniors reviewing AI-generated code that explaining why is it or isn't good. They treat AI as a tool for exploration, not a replacement for understanding. And weak teams, on the other hand, use it as a crutch. They measure output in lines of code or PRs merged, and they don't ask whether their junior developers are actually learning. The difference compounds over time. Like 6 months in, it might not be that obvious, but 2 years in, you have very different teams. This graph represents the question we don't have a complete answer to yet. Traditional learning curves are well understood. You start slow, steady progression. Eventually, you plateau at high skill level. What does the AI-assisted learning curve looks like? We don't really know yet. Anecdotally, people get productive faster, but do they reach the same ultimate skill level with AI? Or is there a trade-off? I'm showing this as uncertain because it is. We won't know the full impact for another few years, but it's worth thinking about now while we are shaping these practices. Let's get into local development. So local development is where AI is most useful and least risky. That is where experimentation makes sense, but configuration matters more than people realize. AI should not see secrets, configs, or credentials. That should sound obvious, but I've consulted with teams where AI tools had access to environment files, AWS credentials, Azure credentials, and database connection strings. Here's a practice that works. Create an AI ignore file or whatever your tool uses, and be explicit about what AI cannot see. Treat it like you treat like git ignore file. It's a security boundary. Teams that write down simple norms, even just one page, avoid many problems. Real example of a good norm is always manually review AI suggestions in authentication authorization code, for example, with no exceptions. This is simple, clear, and easy to follow. Another team had this norm. If you use AI to generate more than 100 lines of code, flag it in your PR description. Not because it's bad, but because it signals to reviewers this needs to be reviewed better, that needs extra attention. And these aren't complicated policies, they're just explicit acknowledgement of patterns that matter. PR descriptions are a fantastic AI use case, I would say. Summarizing changes, explaining intent, saving everyone time. I've started using this religiously after I finish a PR. I ask AI to generate a description. Then I edit it for accuracy, and it gives me a great first draft and forces me to think about how to explain my changes. So this is a win-win situation. AI PR reviewers are trickier. They can catch patterns and enforce consistency, but they can also generate false positives. And here is the problem. Too many false positives train developers to ignore feedback. If your AI reviewer, flags like 20 issues and 15 of them are wrong, people stop paying much attention to the 5 that are right. And I worked with a team that implemented AI PR review. First week, everyone was excited. Like, look at all these issues it found. Second week, it's frustration. Half of these are wrong. And fourth week, people started ignoring it entirely. They fixed it by tuning the AI to be more conservative, only flag high confidence issue, fewer alerts, higher quality, and developers started trusting it again. So critical rule that I cannot empathize enough, humans remain the authority. Many teams now require transparency, like AI assisted yes or no in PRs. That's it, simple flag, but it builds trust because it acknowledges what's happening and sets reviewer expectations appropriately. If I see AI-assisted yes on a PR, I know to pay extra attention to edge cases and implicit assumptions. If it's not flagged, I review it normally. Same work, but better mental model. CI/CD is another powerful and dangerous field with AI. The same automation that makes it valuable makes it risky. So let AI suggest, analyze, and summarize. These are great use cases. Generate change logs from commit messages, like excellent. Analyze test coverage and suggest improvements, very useful. But, and this is absolute, do not let AI merge, deploy, or modify production path autonomously. Here is a horror story. Not my team, thankfully, but someone I know. They set up AI to automatically fix LinkedIn issues in CI. It seemed harmless, right? Just formatting and styling. Until the AI fixed an intentional LinkedIn exception that was actually preventing a subtle bug. The autofix removed the exception and the bug was introduced, and it made it to production because nobody reviewed the automated commit carefully. AI should advise, humans should decide. That's what I continue saying. The rule I use, any action that can affect production requires human approval. And no exceptions, no shortcuts, no, but it's just formatting should be here. This is security's #1 concern with AI tools, and often it's developers' biggest blind spot. Let's be specific about what can happen. IDE tools may send full files, repo structure, and comments to external servers. Every time you accept a suggestion, context is being transmitted. And chat tools are worse. I've watched developers paste entire proprietary algorithm, business logic, and even customer data into AI chat interfaces. Not out of malice, out of convenience and lack of awareness. Here is a real example that still makes me uncomfortable. A developer was debugging a payment processing issue. They copied the entire error log into an AI tool chatbot. And the error log contained customer payment information. Of course, it was masked, but still identifiable. Security team found it out during a routine audit, and the developer had no idea they potentially violated compliance requirements. They were just trying to solve a bug quickly. And mitigation isn't complicated, but it requires awareness. First, understand what your tools send. Read the docs, check the settings, know where your code is going. And second, educate your developers, not through scary presentations about compliance violations, but through practical examples of what not to do. Third, use private or on-prem models when needed, especially when you are in healthcare, finance, or any regulated industry. This probably isn't optional even here. And security here is the most about awareness, not fear. AI tools aren't inherently insecure, but they do create new data flow patterns that need to be understood and managed properly. This is what I mean by blind spots. I took this screenshot from a popular AI coding tool and created this mockup. See all these annotations? That's what's being transmitted every time you use the tool. So most developers I talk to are genuinely surprised when I show them this. They thought it was just sending the specific line of code they were working on. But no, it's sending much more context to provide better suggestions. Is it bad? Not necessarily. But you should know it's happening and make conscious choices about what you are working on. And with these tools enabled, you should be very cautious. This space is still evolving, and honestly, we don't have all of the answers yet. The core problem, AI may reproduce copyrighted code verbatim, and there is no reliable way to provide origin. Let me make this concrete. You ask AI to implement a specific algorithm, it gives you code. That code looks original, but is it? Did the AI memorize it from an open source project with a restrictive license? You don't know. And more importantly, you can't know with a certainty. For most teams, this is a theoretical risk. For regulated industries like finance, healthcare, government contractors, this is a real problem that requires real mitigation. And strategies that work are legal review of tool terms. What does the vendor claim about code ownership? What protections do they offer? Code scanning is also an option here. There are a lot of tools that can detect if your code matches known open source projects. They are not perfect, but they are still better than nothing. Clear internal policy is another thing. Code generated by AI must be reviewed and modified before merging. That establishes human authorship and reduces the risk. And if you are in a regulated industry, talk to your legal team before widely deploying AI coding tools. I'm serious, the conversation might be uncomfortable, but it's better than a compliance violation later. These recommendations come from teams that learned the hard way, and I want to share the lessons they paid for. Start small with AI, start low risk. Don't begin with your payment processing system. Begin with documentation, test scaffolding, boilerplate. Build confidence and understanding before expanding scope. Measure the real impact, not do developers feel faster. Measure end-to-end cycle time. Measure defect rates, measure code review time, measure what actually matters to your business. Review more, not less. This is counterintuitive but critical. AI doesn't make code self-documenting. It doesn't make bugs impossible. You need to review AI assistant code more carefully, not less carefully. And now the don'ts. Don't skip understanding. If you don't understand the code AI generated, do not merge it. I don't care how good it looks and how well it passes tests. If you can't explain why it works, it's not ready. So don't trust AI for security as well. Every security critical piece of code needs human review by someone who understands security. No exceptions here. And don't confuse speed with quality. This is maybe the most important one. Getting to a working version faster doesn't mean you are shipping faster if that working version needs to be extensively reworked. Here is a controversial but important take. Some tasks are worth doing slowly to build expertise. I know that sounds radical in our move fast culture, but hear me out. If you are a junior developer and you let AI generate all your boilerplate, you never develop the muscle memory and pattern recognition that comes from writing it yourself. The goal is not maximum AI usage. The goal is optimal AI usage, and use AI to accelerate where acceleration matters. Use human effort to build capability where capability matters. And those aren't always the same places. So we've covered a lot, so let me leave you with one of core ideas. AI-assisted coding is here to stay, and the question isn't whether to use it or not. The question is how to use it well. The teams that succeeded won't be the ones that use AI the most. They'll be the ones that understand its limits, integrate it intentionally, and keep human judgment central. 3 things to take away. Number 1 is AI is a tool, not a teammate, and treat it accordingly. It doesn't understand your context, your constraints, or your trade-offs. Number 2 is faster isn't always better. Sometimes the slow path builds the capability you need for the future. And the last one is be deliberate. Every time you see AI, make a conscious choice. Don't let AI become the default without thinking about whether it is the right choice. I'm happy to discuss how this applies to your specific teams and workflows. So we've got some time for questions now. And also, you can mail our team if you want to chat more specifically about your situations. So thank you, and the questions are welcome.
Thank you, Andres. Thank you so much. So now we have the time for questions. So feel free to post your questions. And I can see that we already have some questions. So Andrei, the first one is, how do you measure AI impact?
So as I said during this presentation, we used to track end-to-end cycle time, defect rates, and code review time to avoid vanity metrics. Because when you measure only how developers feel, that's not too accurate.
Mm-hmm. Okay. Also, we have another comment and a question. So, Andrei, thank you for presentation. This is a comment from Dmitro. Really enjoyed it. And do you think that this increased attention to code reviews will result in better quality code long term? Most projects I worked on didn't treat reviewing seriously, so I imagine many projects could benefit from having to spend more effort on them because of AI concerns.
Yeah, I agree with you, Dmitry, and it's usually about the trade-offs, in my opinion, because I always also work in teams where we need to deliver things fast, and code reviews is very underestimated part, and mostly if you have bigger teams, many developers can be unaware of some specific context, even of some pull requests, which makes some hidden errors appear. And yeah, I hope that like deeper reviews will make it better, but still having deeper reviews in the teams is something which is hard to introduce, let's say, because once you have tight deadlines again, you probably will not spend like an hour reviewing a PR or something like that. But yeah, I hope it will get better.
Yeah, thank you, Dmitro, for your question. And another one is, what about junior developers? Is AI hurting their development?
So again, as we discussed, it depends entirely on how it's used. With mentorship, it can accelerate learning if used properly. If junior developer is not just AI operator. So without it, it becomes just a crutch. This is when we are starting to see so-called wipe coding phenomenon, which we see all over right now.
Yes, okay. And we have a very important question. So, Andrei, have you used AI during preparation of this webinar?
Yeah, that's a good question. Of course I did. Of course I did, because all of us need to speed up some processes. And one of the places where I used it mostly for this presentation is I, for example, gave the AI some skeletons and some basic notes for my slides to help me to extend them with some information and help me to make it more pretty, because, it's good. I like to use it for drafting. I'm drafting like the use cases that I mentioned here. I'm drafting the important notes I should mention, and I like how it's structuring things for me.
Nice. Thank you, Andrei, for your answers. So let's have just a few seconds if we're going to have more questions in our Q&A chat. And then I think that we can slowly wrap up. Okay, so for now, I don't see any more questions. I think we can wrap up our session today. So thank you so much, Andrei, for the insightful session. And thank you to everyone who joined us live today. You can see all the applause for you, Andrei. Well done. And we hope this gave you a grounded view of what AI-assisted coding looks like in practice, where it works, where it doesn't, and what to keep in mind when integrating it into your workflow. If there is a topic that you'd like us to cover next, let us know. We're always open to suggestions. And if you're exploring how to use Azure and AI in your own development setup, feel free to reach us out to CIGen team for a free consultation. And see you next time. Bye, everybody.
Yeah, thank you. Thank you all. Have a great time. Bye.